The great thing about Agile is that you know how screwed you are really early on. The purpose of Agile is to destroy hope.
Welcome to Children, protect me from the where CTOs share the tales and the comments. So startups do big names and their visions unfold. How many CTOs will share their stories untold?
Welcome, everybody, to another episode of the How Many CTOs Does It Take podcast. My name is Brad Hefta-Gaub, and my trusty co-host is...
Got Porad. Welcome, Brad. We have a special guest with us today.
Yes, we do. Would you like to introduce our guest, Scott, or kick it to
Sure.
him?
I'd like to introduce everybody to Robert Barton, or Uncle Bob, or Bob as he likes to go. Uh, Many of you may not know him, but he's been influential in almost all of your software engineering careers, even without knowing it. And we feel really fortunate to have him here today to talk to him about what he's been doing lately, what he's been doing lately, and some other things. So welcome, Bob.
Thank you very much. Glad to be here.
Could you take just a few minutes for the 40 people that listen to our podcast
60.
and
It's up to 60,
60
Scott.
and just tell them your background. You've been doing this a long time. You've been influential in our industry, and not everybody knows who you are and what your role has been. So we'd love to hear it.
Let's see, I'm 73 years old. Wrote my first line of code when I was 12. That would have been in 1964. And the thing I wrote it on, I've got it over here.
Oh, this is
So this
amazing.
is going to be interesting.
This is great.
Okay,
I
so
love.
here it is. This is
Oh,
a 3-bit. You can see the 3 bits,
Love it.
right? They slide
wow.
back and forth. There's three little flip-flops in here, and you crank it, with that little crank. And if you set it up properly, this will count in binary. It will count from 0 up to 7 and back to 0 again. If you set it up a little differently, it'll count down from 7 to 0. You can have it play the game of NIM. You can have it add 2 bits and produce a sum and a carry. There's a whole bunch of things you can do. Essentially, it's a 3-bit finite state machine. But at the age of 12, this thing fascinated me. This was a birthday present from my mother.
Hmm.
And I put it together and I worked through all the puzzles and I knew what I wanted to be for the rest of my life.
Bob, is that the actual original device that you got at 12 years old?
Yes, this is the original.
That's
Wow.
Yes,
fantastic.
it
I
is.
love it. I don't have my VIC 20. Huh, doggone
Well,
it. Do you
I
still
do
have your
have
VIC?
a Commodore 64 over here.
Nice. Of course you
It's
do.
under
Of course,
it's under glass.
of course, of course you
Wow.
do. I love it. I love it.
And I don't think I can show it to you, but there's a Mac 128 over there. And then this thing over here is a PDP-8. See the blinking lights?
Yeah.
Hmm.
Well, it's actually a Raspberry Pi simulating a PDP-8.
Love it.
Yeah,
Love it.
it's fun. So I was a programmer from that point on. I got my first job out of high school at 16, a temporary job writing a little bit of assembly language. Got another job at 18 that was full time, writing more assembly language for mini computers because that was the age of the mini computer, right? And they had maybe 4K of core or 8K of, some of them actually had RAM. And that was some of them were modern enough to not have core memory. I
Wow.
spent probably 15, 20 years doing assembly language in various industries, telecommunications and shop floor control, aluminum die cast shop floor control, all kinds of stuff, writing code in assembly language for mini computers that controlled devices, did a little bit of laser trimming, controlling a laser trimmer. Eventually got into C. That was like the late 70s. Late 70s got into C. I had been of the opinion that compilers were for weenies. Real men wrote assembly language, damn it.
Of course.
Hmm.
And, and then I got a copy of Kernahan and Ritchie, and as I read it, I realized that was an assembly language. It was just a better assembly language. And so I very rapidly transitioned into C, and then from there, bit by bit into C++, and then Java, and so on. Yeah, I've been a programmer for over 60 years,
Yeah.
and I
Wow.
still write code. Well, actually, now I control agents that write code. But
Exactly.
I still have my hands on the keyboard, still producing software.
Love it.
Are you still producing software commercially or professionally, like for clients, or are you just doing it because it's fun and you've been doing it since you were 12?
Why would I ever stop? No, no,
Right.
yeah, no one's going to pay me to write code anymore. Right? So yeah, I just do it for fun and for research. I'm still writing books and I'm still writing articles and I still try to have an impact on various social networks, mostly X nowadays.
Hmm.
And I try to make sure that I know what I'm talking about by actually doing it. And I mean, what would I do with the rest of my day? I'm going to be writing code. I told Kent Beck a long time ago, right? They will find me with my nose stuck between the keyboard keys, if there are any keyboard keys back then. I want to code for the rest of my life.
Yeah. Of
And
course. Why not?
I don't want that to end anytime soon.
Yeah. I love it. I love it. By the way, I don't want to like get too far ahead of ourselves now, but it is so it resonates with me that you describe your passion as coding and and now in a world where we have these AI agents, these LLMs, these token prediction machines that are doing a lot of the coding.
Yes. Yeah.
But I consider myself to very much be a coder, even if the bulk of my coding is orchestrating agents and then keeping them online, keeping them in line, keeping, you
Yeah.
know, keeping tabs on them and keeping the, making them deliver the quality that I want to deliver as if I was the one typing the code.
Yeah, absolutely. I mean,
Yeah,
they're not going to take responsibility for anything. It's
they
your
aren't.
butt on the line. So,
Yeah, absolutely.
you've got to whip them into shape.
Yeah, absolutely. So somewhere between 12 years old and uh today, you also have written a lot of books and you have been part of the movement of the Agile movement. Would you like to share more about like how that came about?
Oh my goodness, the Agile movement. This began in '95. And it came to my knowledge in the design patterns movement. So a bunch of guys started the whole design patterns movement. Eric Gamma and, a bunch of guys got together and they wrote the book. And early on, I was one of the people reviewing the book. This is back in the days before social networks. So they would put the chapters up on an FTP mirror,
Yep.
and we download it in PostScript, and then we would print it off on a laser printer, and then we'd review it, and then we'd email back and forth about it. That's where the name the Gang of Four came from that email group. And in that rapid discussion period, a number of thoughts about getting rid of waterfall started, right? Can't we do something more lightweight? This whole, upfront planning thing hasn't been working for us. We need a better way to do it. And along comes Kent Beck, who is a big part of the patterns community. And he says, well, there's this thing I've been doing called extreme programming. And I got really heavy into that. I said, Kent, that's exactly what my clients need. It's what the industry needs as a whole. And he and I and Martin Fowler got together and we concocted this scheme to do extreme programming courses. And these were like 5-day courses. They went from 9 in the morning till 9 at night. We built special tables so that people could pair program around the tables. We'd have 60, 70 people coming in there, and this is like at the height of the dot-com bubble.
Yeah.
Hmm.
So everybody was doing anything they could to get hot on extreme programming. And in the midst of all that, there's some other lightweight processes that were beginning to get popular. Scrum was one of them. There were a few others. And it occurred to Martin Fowler and I that we ought to get everybody together. So we convened this thing at Snowbird. What was this, February of 2001, I think? We sent a whole bunch of emails out. A bunch of people responded, those who could afford it and wanted to join. And we all met at Snowbird. And I stood up and said, "Hey, we need a manifesto." And I sat down, and that was the end of my contribution. And then everybody else kind of brainstormed it out. And in the end, up pops the Agile Manifesto on a board. right? It was written there on a board. Nobody knows quite for sure how it got there. Nobody remembers properly. And then a day later, down in the basement in a different room, we had a vote about what to call it. And one guy said lightweight. That was me. I said we should call it lightweight. Everybody hated that idea. And another guy said we should call it adaptive, and everybody hated that idea. And it was John Kern who said, "Well, the military really likes the word agile right now," and the rest of us are going, "Oh, that's a terrible word." But we voted on it, and agile won by a vote.
Hmm.
And then it was Ward Cunningham who said, I'm going to take this manifesto, I'm going to put it on my website, I'll get a special domain name for it. Here was the key insight, right? I'm going to write some code that will allow people to sign this. And this is 2001. Dynamic websites were like brand new.
Yeah.
The act of changing a website from a user, right? That's like very different. And Ward Cunningham writes that, and tens of thousands of people signed the doggone thing. Who knew? That's the story in a nutshell. If you want a more complete story, by the way, let me get a book down here. I wrote the whole story in that book.
Is that right?
Yeah, the whole history, the whole sordid history of who did what to who when. It's all in here. Along with, what this agile stuff really is, because it's not what everybody thinks it is. I wrote that book about 8 years ago, 7 years ago, something like that.
I've got two questions here. First, for the people who are not watching video, that book is called Clean Agile, Back to Basics, so everyone knows. I have two questions, Bob. The first is, you were experimenting with lightweight frameworks. Other people were experimenting with lightweight frameworks. What was it? That was in response to something, and you were trying to get from some place to some other place. What were you reacting to that was causing you and others to be trying to do something different?
There were two competing ideas in the industry, and one of them was some kind of lightweight iterative process. Barry Beam had done the spiral model years before, and everybody looked at that and went, "Oh, interesting." But you've still got to have a big plan up front, and you've still got to lay it all out, and you still have to do the analysis, and then the design and implementation should be easy if you've done the analysis and the design. That was a mindset that was so thoroughly entrenched that it took a very long time to shake out of it. And sometime in the 90s, we the ones who were old at the time and had gone through that and had been proponents of it, had to look back and say, yeah, well, that didn't work all that well. And there's this other school of thought, which is maybe we should just do it in tiny little iterations. Maybe we should just work the way that programmers are observed to behave in the wild. That was a catchphrase that we used to use. And so, okay, then we started playing around with that. And Kent Beck was one of the ones really early who did this. And there were a number of other people, Ken Schwaber, Martin DeVoe, Jeff Sutherland. They all kind of started to play around with this. Alistair Coburn started to play around with it, started to mention it at the patterns conferences. And we all kind of went, there's probably something to this. And that's kind of how it all happened.
And fundamentally, what wasn't working about the previous method was the software wasn't very good, or it was expensive to build, or
it was
not fun.
Well, it wasn't fun. That's number one. But what wasn't working was the idea that you could analyze everything up front.
Yeah.
And then design everything up front. And then the code would come out just so easily. And what you discover when you do that is when you start writing the code, when the rubber actually hits the road, it goes in a completely different direction than anybody had thought. But you don't now have time because you've blown all this time on the big analysis and the big design. And you've also got people looking over your shoulder saying, you're not following the plan. And the developers are sitting there going, yeah, but we can't.
Yeah.
The plan doesn't work. This thing we spent 6 months on does not work, and now we've got 2 months left, and we're just going to have to hack like crazy.
Yep.
That was kind of the normal theme of doing software throughout the 70s and the 80s and into the 90s.
Yeah.
Hmm.
I remember that, Scott. You started in that time frame too, but I definitely remember that in the, you know, in my professional career from like my first, paid software gig was 89, and by 95 it's like it always were these big projects. They were like 2 year long, 3 year long software release cycles where you spent the first 6 months, first year of that 2 years, like specking things and designing things. And then you didn't really start writing code until halfway through your allotted time budget. And yeah, like the classic example is, you know, developers like has implemented some code and eventually QA is looking at it and it's behaving a certain way. And it's like, what's the spec say about this? And the developer's like, the spec's silent on this. Like the spec completely didn't even consider this idea, but we realized it once we had the other pieces together. Like, it's like a big jigsaw puzzle and you got all these holes in it. You're like, oh, the plan didn't even account for this whole side of the jigsaw puzzle. Like we had to put something there.
Yeah, so Agile comes along and says, you can use feedback for this. You can have the customer on the team with you. And as you're putting it all together, they can say, no, I don't like this. Yes, I do like that. Every week, every 2 weeks, and evolve the system in the direction that the customer wants to go, which also takes advantage of the fact that the customer doesn't really know what they want. So if you
Yeah.
ask a customer for a spec, well, they'll give you one, but it's a lie. It's a complete fabrication because they don't know what they want really.
Yeah.
Hmm.
But if you show it to them and they can guide it, then it's a much better approach. Not perfect, but it's a much better approach.
So, Brad, I didn't start professionally until 95.
Oh, okay.
And I have always worked in online systems. So, like, I'd never worked on a shrink wrap piece of software before. And so, even though we were still doing big waterfall kind of things, there was just by the nature of the fact that we weren't having to put it on a disk or a CD or whatever and ship it to people, meant we could, even before the notion of agile existed, we could kind of be a little more agile. If there was a problem with it, we could go fix it.
Yeah.
Maybe not as fast as we wanted to. So I've always so when the stuff that Bob and others were working on started to come along in the early 2000s, it was very natural. It was just like, oh, this is just taking kind of the friction we've been feeling in terms of trying to build online software and really, I guess, taking those shackles off, I guess is kind of what it felt like.
There's an argument to be made that it was the beginning of the internet and the web that was really the catalyst for the change from the big, heavy upfront plan to an iterative approach. Because everybody wanted to see that stuff on the screen. And then
Yeah.
Hmm.
everybody would start commenting about the stuff that was on the screen.
Hmm.
Right? And that could have been the catalyst, probably was at the time.
I this is a little side quest, but so in 1998, I was part of a team that launched this website called drugstore.com, which
I remember
ultimately
this. I
became
bought stock in
ultimately
that.
I hope it did okay for you. Uh, I remember we spent a while getting this thing built and we launched it. And I remember the day we launched it, or maybe the day after we launched it, people wanted changes to the
Oh yeah.
website.
Yeah.
And I remember sitting with this guy, his name was Zach Strelo, and we didn't have any method for change. We only had a method for like getting it out there once. We didn't have any plan for like how are we gonna make changes, right? And we figured out branching and source control and all that stuff. But it was your point about how the internet brought that along resonates with me because people saw it and they were like, "Oh, that's not what we wanted." Okay, so you said something about your book that I want to ask. You said this book says what agile really is, not what happens out there. And so where do you see the differences? What do you see happening out in the world versus what the spirit of it is?
Agile got completely invaded.
Mm,
The space got invaded by the project managers, and you could blame this on Ken Schwaber indirectly because he's the guy who came up with this idea of the certified Scrum Master.
mm,
Now, little story. Ken came to me one day and said, "Bob, I'd like to use one of your classrooms." I was running a training company at the time. I had classrooms. "I'd like to use one of your classrooms, and I'm going to teach this course. I've never taught it before, the Certified Scrum Master course." And I looked at him like cross-eyed and said, "Well, okay, go ahead, Ken. You can do that." And I thought it was a terrible idea. Um, Turned out that it was a great idea because tons and tons of people wanted to become certified Scrum Masters, but not programmers. It was all the
Mhm.
project managers. And the project managers invaded the space and they completely took it over. They took over the conferences, they took over the messaging, and literally pushed the programmers out.
Mm.
Agile was started by a group of programmers, and within about 3 or 4 years, the project managers had put the programmers off into a little cubicle somewhere and had taken over the entire messaging. And it
Mm.
was a disaster. It was just awful. In the meantime, you've got all these consultants out there who grabbed onto the word agile or scrum, and then they're adding adjectives onto the end of it, so, or onto the beginning of it. So there's fast agile, and there's special agile, and there's stable agile, and all these different consultants are pouring into the industry, trying to differentiate themselves from each other, and you wind up with a absolute chaos, which is kind of the way the world went. And I wrote this book, and the book is like, do you remember how this began? You know, Agile was a small idea about the
Mhm.
small problem of getting a small team to do small things. It's not some big idea. We weren't trying to take over the world. We just wanted to solve this one problem of
Mm.
getting a team of 6 or 7 people to actually be able to work well together.
Mm.
Yeah.
So
Yeah.
that's what the book is. It just tells the same story I told you, but in a lot more detail. And it outlines the disciplines and the procedures that we used at the time.
What something you just said sparked a totally different question on my mind, which is you talked about how it was a small idea for small teams doing small things.
Yeah,
And here's a tension that I feel a lot. We're trying to be, on the one hand, you have just called the engineering team, roughly speaking, but that includes other people like designers and product
yeah,
managers, but called the
yeah,
product development team. They're wanting to be iterative and agile. Okay. And then you have, at least in the context I've worked, which is within a company, the business, which wants to have they want to have a roadmap. They want to have a horizon of things that are going to
sure.
happen, and they want to know when they're going to happen,
Yeah,
and they want to know it. And it's like
sure.
those two things are at odds with each other. Of saying, well, let's just start programming and see what happens, versus this is what we want to do for the next year or two or three.
Sure.
What's your thoughts on that tension, or how to reconcile those things?
Have you ever been in a sales meeting? CEO sits there with all the sales guys, and what does the CEO ask him? What's the sales forecast, guys? How's it all going to
Yeah.
play out? And they all give their estimates. And then you turn around 1 quarter later and they're all completely different, right?
Right.
The job of managers is to manage that uncertainty. And of course, they don't want the uncertainty. They'll do anything they can to avoid the uncertainty, but it is their job to manage the uncertainty. That's why we have managers. And the same is true in software, right? So yes, the managers in software want firm dates and they want firm specifications. That doesn't mean they can get them.
Mhm.
And if you attempt to give them, you're lying. Our industry has been punctuated with that kind of lying for decades, right? See, some manager comes along and says, "Okay, when's that module going to be done? We need it by next Tuesday." And the developer says, "Okay, I'll get it to you by next Tuesday." Well, they don't. So that was a lie. And sometimes the developers will say, "Look, I can't get it by Tuesday. Maybe I could get it by the following Tuesday." And then the manager says, "Well, will you at least try?" Which is a completely invalid question. I mean, what is the guy doing? He's not trying. What
Right.
is he supposed to
Right.
pull some
Right.
magic beans out of his pocket and say, "Okay, I'm going to try now"? I mean, it's almost insulting to say, "Will you at least try?" And yet that kind of browbeating and that kind of imposition has an effect. And developer says, "Okay, I'll try." And the reason the developer says that is because he wants the manager to go away. Right? Right? He's telling a lie and he wants the manager to go away. This is a big part of my message to developers, right? You never say you'll try. You never give a date. You give a range of dates. You make sure everybody understands it's always a probable variable, right? It's always an uncertain thing. And then you put it back on the manager. Manager, your job is to manage uncertainty. And I'm giving you the size of what I don't know. So it could
Mhm.
could be 2 weeks, it could be 3 weeks, it's going to be somewhere in there.
I used to say, Bob, if a developer gives you an estimate and in that estimate they use the phoneme to, then they're just making it up. So they could say, I'll get it to you tomorrow, tomorrow. I'll get it to you in 2 days. I'll get it to you in 2 weeks. It's all just made up. And the giveaway is the phoneme too.
You asked a very fundamental question. How do you resolve the tension? The answer is you don't. There
Yeah.
Hmm.
isn't any way to resolve the tension. That is the tension of business. And
Hmm.
it's the tension of every facet of business.
And the reality is that Waterfall doesn't solve this either, right?
No,
This
we
is
thought it did,
Yeah, this was the classic.
right?
This is the
Yeah.
classic problem, and I can't count the number of times that I mean, less so now, but you get maybe a non-technical executive who says, "I don't understand why the engineers can't give a better estimate, right? Why are we doing this? Why are we doing this like 2 week sprints, and we will see what we get at the end of the 2 week sprints?" And I think that that's the challenge. That the reality is that these other heavyweight techniques that claim to provide certainty actually did not work. Like the track record, those didn't also provide certainty, right?
No, no. It's
And
just that they delayed the knowledge of uncertainty until it was way too late.
which is even worse. Which
Yeah,
is
it's
even worse.
even worse. The
Yeah.
great thing about Agile is that you know how screwed you are really early on. The purpose of
That
Agile
is
is
the
to
quote.
destroy hope.
I got to write that. I mean, the quote. So the purpose of Agile is to destroy hope. I have to write that down.
As early as possible.
Yeah.
Okay, so Bob, I'm gonna do a hard tack here. We've been talking about agile. And I'll incant the AI. Well, I'll throw this out. One of the movements that I see going on in AI, I feel like there is a classic battle of waterfall versus agile actually happening in the way that people are thinking about AI,
Yeah. Yes, it is.
right?
Yeah.
And for example, there's a group of belligerents that are very adamant that we need very, very high quality specifications up front, and they have built tooling like spec kit and spec driven development and things like that uh, before they hand it to the agents. And then there's another group that I think are, I'll call them a little bit more like the agile belligerents, but maybe we'll just call them like vibe coders, where
Yeah.
they're literally just hitting the slot machine arm and just getting something random, seeing if they like it, and then pulling it again. And that's a pretty wide spectrum. What say you, Uncle Bob? Where
So,
where on this spectrum is there goodness, and where on this spectrum is there pain and chaos just waiting to bite us?
so the lesson of Agile still applies, right? The customer doesn't know what they want. We don't really know how to give them what they want. We're going to have to move in little steps and validate at the end of each step and be able to course correct all the time. So that still applies, which flies in the face of the big upfront plan. So yes, you're right. There is a bunch of people out there saying the only way to deal with agents is to give them a great big spec up front. Well, that doesn't work, right? For the reasons that we just talked about. On the other hand, the vibe coding idea doesn't work either. You cannot just sit and type at an AI and say, "Now do this, now do that. Oh, this is cool. Now do this," because the AI will build code upon code upon code upon code until it all collapses on itself. And this is a problem we identified very early on in Agile. Right? Agile had three layers to it. Right? There was the outlooking disciplines, the disciplines that looked out from the developers to the business. And that was things like estimating and planning and continuous integration and so on. And then there were the inner disciplines. These were the engineering disciplines, test-driven development, pair programming, simple design. They were extremely detailed and they altered the way a developer worked on a minute-by-minute basis. Right? It was a completely different way to work. And that's what we're missing in the AI space, it seems to me, those inner disciplines. And that's where my focus has been the whole time. How do we get these agents to be flexible enough to work in an agile way so that you can course correct quickly, but also disciplined enough so that they're not piling slop upon slop upon slop and building a tower to heaven that's going to collapse on itself? And so a lot of the work I've been doing is along those lines, trying to come up with a set of disciplines that the AIs themselves can follow not because of rules, but because of tools. Tools that they must execute. And those tools tell them yes or no. And then the AIs have got to spin on those. They've got to, okay, I've got to get to yes somehow. And the yes is usually something like, I want my methods to be small. I want there to be very little duplication. I want my modules to be under a certain size. I want the dependencies between modules to run in a certain direction. All of the rules of architecture, all of the rules of clean code and good design, you can capture as a set of tools that the AIs will spin on, and when they're done spinning, you will have a reasonable approximation of good code.
I mean, those are all the same rules that you would apply to the human developers.
Of course,
Yeah.
except you can't, you can tell a human developer, keep your methods small. If you tell an AI that, they'll do that for the first 10 minutes and then they'll forget. They cannot remember, the context window gets too big and it gets lost in the middle. And the thing about AI agents is that they get super myopic, right? They focus and they're really good at focusing. But as they're focusing, every other rule you ever told them just goes away.
Right.
If you let them, they will change tests that used to work just so that they can make the next thing work.
Yeah.
They will break features in order to make new features work. They will do every horrible thing that can be done to code in pursuit of the current myopic goal. And you've got to get them in the way of that and stop them from doing it.
Yeah.
How do you do that? Is that other agents getting in their way and looking at their work and giving them
No,
feedback? Is okay.
no, tools, deterministic tools,
Okay.
programs that they can run that measure things.
Oh, I
Measure,
see. See.
how much duplication is in this module, right? Get a module
Hmm.
in there. Now just start looking at the lines of code, and you can do that with a program. It's a real simple program.
Hmm.
Just look at find duplication, eliminate the duplication. The agent is very good at eliminating duplication. They're not good
Yeah.
at finding it.
So, for instance, you would ask an agent to write some code, and you would also say, when you're done writing this code, run these tools against what you wrote and ensure
Yes.
that it's essentially like a form of tests.
Yes.
Yeah.
Yes. It's one of the tests.
Yeah.
Right.
And
And no,
these deterministic tools often are able to work essentially through static analysis of the code. And
yes.
therefore, we know it's deterministic. We know that it will produce the same results every time it looks at the same section of code.
Yeah.
It's not a token guessing approach, right? Which the LLMs are, the transformers are. It's deterministic.
Yeah. It's not stochastic. There's no probabilities involved. Right? The tools are programs. And I have the agents make the programs for me. So
Yeah.
one of the metrics I really like is called CRAP. And it was invented in 2007. And there was a tool at the time called CRAP for J and for the Java environment. And what it does is it measures cyclomatic complexity, which is the number of pathways through a function, and it combines that with the test coverage. So it measures the test coverage of a function, and it measures the cyclomatic complexity of the function, and then it combines those two into a raw number. And the number works like this: if you have 100% test coverage, then your score is just the cyclomatic complexity. If you don't have test coverage, the score just skyrockets, right? And I tell my under the theory that a really complicated function that's not tested is really, really crappy.
Right.
So I have my agents bring that down to 6. No function can be above 6.
Hmm.
And they're happy to write 12s and 20s and 84s. But then you run this tool and they're going, oh my God, I got to get this down to 6. And how do they do it? Well, they've got to cover it. So they've got to write unit tests.
Yeah.
And they're writing unit tests and they can bring it down a little bit, but it's still too big. Then they have to take the functions apart into a bunch of littler functions. Right? And this is all exactly what you want them to do.
And this is what you'd want a human developer to do as
What?
well.
Yes, you would, but a human developer would do it more naturally, not under the whip of a tool. The AIs need the whip.
Yeah.
Hmm.
You kicked a hornet's nest on the internet recently, Bob, when you were quoted as saying, or at
Oh,
least
really?
the way it's been uh, repeated is, I don't read the code anymore.
Right. Yeah,
So
that's true.
yeah, so first of all, I'm curious to hear from you. Why do you think that caused such a kerfuffle? Why did that blow up the internet?
Well, there's a bunch of reasons. Number one is if anybody's used an agent before and they look at the or just told ChatGPT to write code for them, and then they look at the code and they're horror struck, right? Because a lot of times the code comes out really bad. So if that's what they're thinking, if they're thinking I'm just telling the agents to write code and I'm taking whatever the agents give me, well, yeah, they should be horrified. They should be
Yeah.
horrified by that. Then there's another faction, and that faction is people who say, um, my identity is writing code, and you're telling me that that doesn't matter anymore. Now, that's not what I'm telling them, but that's how they infer it.
Yeah.
And so there's this identity crisis. And so they reject the idea. No, no, we still have to look at the code. We are the owners of the code. And I reject that. I think, look, these tools are so good, they're so productive. There's got to be a way to take advantage of that productivity. And the worst thing you could do would be to insert a human into the syntax loop, because that's the thing we're bad at. We're
Yeah.
bad at syntax, right? They're really good at syntax. So let's get the agents to deal with the syntax problem. And then we, the programmers, can take one step back, maybe a half a step. Not much, but we don't have to look at the code. We can look at the output of the tools. We can look at the behavior of the system. We can look at the number of tests. We can look at the coverage numbers. We can also do very interesting things. Agents are very good at introspection. You can ask them questions about the structure of the code. And you can ask them leading questions and they can find nuance. It's really cool to do this. And every once in a while, you have to kind of sit back and go, holy shit, these things are really good.
Yeah.
And once you get them to focus, they'll tell you what's wrong with the code they just wrote. They will not apply that on their own, but they will tell you, oh yeah, these modules are too big. And then you can direct them. And you can say, okay, you should split these apart. I don't want the unit tests to be intimately connected to the code. I want an API in between them. Oh, yeah, good idea. I'll put an API in there. I don't want the IO being called from the web page. Oh, yeah, I can put up, you
Yeah.
know, all of those things that you and I would look at code and go, what the hell did the guy do that for? You can still infer that and then direct the agents to do the right thing. So I like to pull back from the code a half a step. I don't want to look at the code. I don't want to look at the syntax because that'll slow everything down. But I can still tell, my spidey sense works. I can still tell what's going on in there. And then I can direct the agents to do the right things.
Yeah.
And that, so far, that has worked really well for me.
So you said something earlier that sometime in, say, it's early in your career, I think maybe the late 70s, you switched from writing assembly to writing C.
Yes.
And one of the comments I've made sort of offhand to people in my world who are uncomfortable with not looking at the code, I said, well, you don't look at the assembly, right? You write code and don't look at the assembly.
Yeah.
And I'm
Yeah.
wondering, and their response has been, well, the difference between the code and the assembly is it's deterministic, right?
No, it's not.
But okay, well, this
I
this
love
is what
it.
I wanted to explore. I'm wondering if you've had this experience already that a lot of people are going through when you made the transition from writing assembly to writing C that others could learn from.
Oh, sure. Going from assembly to C, um, I wrote assembly for like 15 years. So
Mhm.
I knew assembly language and I knew the machine and I knew every bit in the machine. I knew how it worked and how all the flags changed. I knew the whole thing. And then going to C, you have to give that up. This intimate knowledge of the machine, you have to give up. You have to back away one little step and treat the language as if it's talking to some abstract machine that you sort of know how it works enough so that you can get the program to do what you want, but you've lost the intimate knowledge of the fact that there's this bit over there called the link that captures the overflow of the accumulator when you add too much stuff to it. All these funny little flags and address segments and all that stuff goes away. And so the step up just to see is an abstraction. And then you think, well, okay, but it's deterministic. The compiler will generate deterministic code. Will it really? I mean, if it's deterministic, then the code it generated should be the same between different versions of the compiler. But that's
Right.
not true. And it should be the same if you run the compiler on a different operating system. But that's not true.
Yeah.
Yeah.
And
So
and and how
it
many
is.
times have you seen a bug where a compiler bug or a compiler quirk where the exact same section of C code in a different place in the program produces completely different machine code
And doesn't work.
and doesn't work, right? Or
Yeah.
has exactly.
Yeah. Yeah. Oh, yeah.
Hmm.
Sure, that happens. It's rare nowadays. It was much more prevalent in the 70s. Right. So I actually, in the very early days of my C career, I would look at the assembly language that it produced, and I was so horrified by it that I wrote programs that would correct the assembly language that was coming out of the compiler.
Right. This is the point that I think the people that are sort of like saying like I can't trust the AI to write code when I look at it, the code is horrifying. You just said it, Bob. You used to look at the assembly code that the C compiler would generate, and you were horrified by it because you would have written the assembly code differently.
So I wrote a tool.
Yeah.
I wrote a
Interesting.
deterministic tool that would correct that problem. Just what I'm doing now.
Yeah.
History repeats itself.
This attitude is extremely old. When Grace Hopper, this is like 1952, Grace Hopper decides that writing in binary is a really bad idea. And wouldn't it be nice if we could have a slightly more abstract language, which she called a compiler? And she called the idea of a compiler automatic programming. Right? Now, these compilers were impossibly primitive, more primitive than even an assembly language. It was just one tiny little step up above binary. And the programmers at the time felt challenged and they rejected the idea.
Hmm.
Who's going to do? I mean, we're the ones writing the code, and now that thing's going to write the code. What good are we?
Yeah.
And that has happened at every stage. That happened during the OO revolution. It happened during the Java revolution. Right? At every stage, it happens. There's a group of people who feel that they will be disenfranchised. Now, they won't be, but they feel that way because this skill that they have developed over a period of months or years is now looking like it's being devalued. It's not, but that's how it feels.
Yeah, even setting the emotional and the identity part of it aside, what I've learned here today, amongst many things, is there's a pattern we can follow, which you followed when you were moving from assembly to C, and you talked about tools and deterministic evaluation for this stuff, and that's the same pattern we can follow today as we're abstracting one more level up, right? And
Yep.
then another 50 years, when the world abstracts another level up, it's probably the same pattern we can follow again to make this work.
I had not anticipated this level. As recently as 2 years ago, I was writing articles saying that we had plateaued. There were going to be no new languages that were meaningful. We explored the language space. The processors weren't getting any faster. The clock rates had plateaued out. And that programmers in the future were going to be living on this plateau. I went up the roller coaster. I went up the exponential curve, but the programmers from now on are going to be living on the plateau. I can't imagine how wrong I was. I did not anticipate this AI thing coming along. And I started to smell it about a year ago. And even then, I was not convinced. I thought, nah, this is just, this is horrible. I ran a few experiments. I had a ChatGPT. I told ChatGPT to write a C program that would compute the 128th digit of pi. And it went out in Java, and it went out and it got math.py, and it turned it into a string and got the 128. Like, okay, you're missing something there, dude.
That's
I mean,
fantastic.
But
It did
then,
exactly what you asked.
It did exactly what you asked, right?
well, yeah, it
You
sure
probably
did.
said, did you say calculate pi or did you say print the digits of pi out to
I don't
128?
remember. Okay.
Love it.
But since about January, and with the advent of the agents and some of the better models, the early Grok model, the early the early Claude model, the early Codex model, these things have started to get pretty impressive. And in the last couple of months, I mean, Jiminy Christmas, the stuff that you can ask them to do, the abstract way that you can communicate with them and still be precise enough to watch them work and correct them as they go off into Never Never Land. It's just astounding. It's amazing to me that we've gone this far, and now it looks to me like the whole sky is open. Sky's the limit here. There's stuff that we're going to be doing in the next 20 years that we can't even think of right now. It's like, holy cow, we're not on a plateau, man.
Well, let's ask that question in reverse. When you were writing the article about being in the plateau a couple of years ago,
Yeah.
what were the things that were true at the edge of the plateau that weren't true in when you started writing C in the late 70s? Like, we might be able to learn where this AI is going if we say in 1977 we didn't think X was going to be true, and look what happened. And we thought there was a plateau there. Well, actually, I don't know if this is right or not, but clearly the online piece is something we didn't predict. But I don't think that's actually the right space. It's more like in the actual programming space, I think is where the question would be.
There were lots of hints about the online space, even in the 60s.
Mhm.
IBM was on top of that really early on. They had the 3270 screens, the green screens. They had
Mhm.
already invented an HTML-like language. They'd already invented the distributed processing and the browser and server kind of model. All of that had been done, but it was so vastly expensive that everybody kind of ignored it, except for IBM and the people who could pay, several $1 million for a system like that. But the hints were there. And the hints were there, even going from assembly language to C, right? It was easy to say, it's going to get better than C. And C++ came along just a few years later. And when C++ came along, it was easy to see, well, it's going to get better than C++. Don't know how, but it probably will. And then Java comes along and people said, well, that's not better. And well, there's things about it that are better and things that aren't, but okay. And then, Ruby comes along and Clojure comes along and Python comes along and you're okay, yeah, we can see that's kind of a natural progression. This is not a natural progression. There was no way, at least for me, there was no way for me to look at the state of the industry 2 years ago and predict this. Now, other people were, but I had no clue. No at all. None at all. In fact, I used to give lectures at the time, and the lectures were there will never be a self-driving car. I now own a self-driving car.
Yeah.
Right? It's like, okay, I was wrong about that one. I could not foresee this one. And it just came down the railroad tracks like a freight train. And boy, is it going fast right now. It's very
Yeah.
exciting.
Yeah. Yeah. And I think that the breakthrough that really happened in the last couple years was just this idea that we knew that transformers were really good at essentially generating a string of tokens, basically predicting tokens. That's like transformers are fantastic at that. And then the only question was how big the essentially the how big you could how many parameters you could get into it,
Yeah,
right?
yeah,
And
yeah,
so
yeah.
the whole notion of the hyperscaling of like let's just get these to billions and billions of parameters in the transformer, that seems to be the breakthrough that really all of a sudden the scale got to a point where now the things that come out of it can be really quite amazing.
I was yesterday just looking at my website and I thought, this website's terrible. And I used to maintain it by hand. It was written in Clojure, and I would write the Clojure code. And okay, it would take me a day, and I would, do some stuff. And I pointed my agent to it, and I said, "Look at the repository of my website." And it came back like in five seconds and said, "Okay, I understand that. That's pretty straightforward, okay." And then I said, "Okay, now over here are the scripts I use to deploy it." And it looked at that and said, "Okay, yeah, I get that. All right." What I want you to do now is get a thumbnail of all the books I've ever published and put them in a grid on my website. Okay, I'll do that. And just, and then it deployed it, and it's up on my screen. And all of a sudden, I'm in this mode that I'm very, very used to, but not on a website, not on my website, which is looking at the website. I don't like that. Blah, 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 and it's back, and oh, I like that a lot better. Okay, well, okay, now go out and get every tweet where I used the word morning bathrobe rant. Okay, put them on the list. It's all up, and this is like, you know, 2 minutes, 2 minutes, and there's a list on my website of all my bathrobe rants.
Yeah.
And it searched the X place and found them all, put links up there, and it figured out how to do the deployment, and it figured out how to modify the website, stuff that it had never seen before. I just pointed it at it. And the power of that is just so enormous. Why in the world would anybody want to bog that down by staring at syntax?
Well, isn't that, I mean, to bring this full circle, isn't that bringing the promise of agile development true? You were able to say to the agent, do this thing. A few minutes later, look at it and say, it's not exactly how I wanted it. Could you adjust it this way?
Absolutely. Right. I think what happens to Agile is that we had iterations of 2 weeks, and then some people said, well, we do 1 week. I think iterations are 1 hour now.
Ha!
Right.
That's literally what you just said, Scott, like last week. You're
So,
like,
Well, I've been trying through hook and crook to get our product managers and designers to actually sit down at the computer with the engineer to do the coding, meaning the prompting,
the prompting. Yeah.
just just to do it right there. And when they do it, it works and they like it a lot. And it cuts out a product manager writing a document and a designer writing, but sometimes the mockup's useful because you can just feed the mockup to the AI too. But like it just cuts out a lot of these steps where you lose understanding, right? And because if the people are there and they can just have an extremely high fidelity conversation with each other about what they want.
yeah.
Yep.
And goes back to the pair programming stuff. It's like pair programming in a different way almost. Um, and I kind of think that's the way it's going to go. Has to go.
Oh, I'm certain it is.
Yeah, I've told you this story before, Scott, but I'll tell it for Bob's benefit. Like one of the fractional CTO clients that I work with, the team is a super high performance engineering team. They were already, before AI came on, they were very, high quality engineering. They had all these great quality, all these automated quality gates, really great layers of CI/CD where they could, like obviously the developers had their local environments working. They had ephemeral environments that would spin up every time a PR was made. They had staging, they had production, they had all this automated gates. And then once AI became practical, they just like they just started accelerating, beyond scope that I could imagine. Like the thought experiment I like to say to people is imagine you hire a developer on day one of their job, they give you a 3,000 line pull request, right? And you say, "Oh, I've got danger rules that don't let you have more than a 200 line PR." And I'm like, "Great." So they give you 15 PRs of 200 lines, But the reality is you can easily and I challenge the teams to say like what you can no longer read that code. You can know your old processes aren't going to work for you. So what processes are you going to have instead? And the answer is, as you've been saying, Bob, it's tools. It's like get the tools that basically have the quality gates that are important to you that no you shall not pass unless this quality gate is met.
The agents will build those tools and they'll build them in an hour,
Yeah.
right?
And the thing that's interesting is, so then in one of these teams, the other thing I see people like panic is, oh, if you've got production software, you can't let non-developers write code for your production software. Well, this team, the CEO, who is been a technologist but is not a computer scientist, never classically trained. In fact, I believe he's classically trained in music, right? He's now writing code. He's now building features that ship into production just as quickly as the developers because he's got all these quality gates that force whatever his agents generate. It meets the same quality bar that the true developers on the team would have also generated. I'm absolutely convinced that if you've got great quality gates, and I love the ideas that you're bringing up, Bob, about the tools like crap and things like that. That's those are even better layers. But if you've got those great quality gates, you really can, anybody can become a coder, right? In the original sense of that. I have an idea and I want to see the machine implement it.
So that's true. There are insights that only an experienced developer can have when things start to go squirrely.
Yeah, that's fair.
Right. So there's nothing wrong with the CEO or whoever he is typing prompts and getting features up. But the guys who've been around the block a few times, when they're watching the agents, they'll start to smell things going wrong.
Yeah,
And nobody else is going to smell that. And then you have to get in there and kind of say to the agents, okay, move this over here, move that over there. Don't do that thing you just did. And that's fairly important still. That may go away as the years go by.
yeah,
The agents may get smart enough. Right now, they still do fairly dumb things that could be invisible, and
that's
the tools don't catch.
that's fair. I also think, by the way, it's this pulls on the thread that I think other people are asking, which is how do we teach the junior engineers? How do we teach them how to have that sense of smell, that sense of code smell, bad smells? How do we teach them that? I'm convinced that the answer I give is build as much as you can
Yeah.
and use the agents to build stuff. That's fine, but read the code. Don't be like Uncle Bob. Read the code, and when you don't understand why the agent wrote the code that way, ask the agent why they wrote the code that way, right? Like I tell people like this is how I learned to program. I read the code of other developers and I asked them to explain it to me. And then I wrote code and had them critique it and asked them to explain their critiques to me, you know? And I think you can still do that even in a world where maybe the actual syntax, to your point, Bob, has been written by the agent. Be curious about it and interrogate it. Everything. Interrogate everything.
Interrogation is a really good approach with the agents because they're very good at responding to interrogation. The issue of how do you train new, people coming into the industry is an important one, and I don't know the answer to this. One of the ideas I tried to promote a while ago was bring a guy in from school, um, and treat him like an agent. Give him tasks, let him do it, treat him just like an agent, run the tools on him. Right? Okay, you've written that code. All right, now I'm going to run these tools on you. And have him play all the different roles that the agents play. Right. So there's a coder agent who writes the code. There's a cleaner agent who cleans up the code. There's an architect agent that restructures the code. Have him play all those roles over the course of, I don't know, a few months. And that might provide the insights that are necessary. But I think it's going to be a really interesting problem, an interesting issue over the next 5 years. How do you bring new people into this industry and have them develop the insights that are going to be necessary to guide these agents who will, without those insights, run roughshod over you.
I don't think the industry is ready to adopt what I'm about to suggest, but I actually think the right model is more of an apprenticeship model. So recently, we just did some work on our house, and the company that did the work, like, there's three generations of carpenters that worked on this. There's the guy who taught the second group of guys who are now teaching the young guys.
Yep.
There was no book that was going to teach the young guys how to do it. They just got experience at doing it with their, I guess, what's the craftsman? I guess that's an apprentice and a craftsman, right? Kind of supervising and teaching and providing feedback. And I don't think, like, from industrial perspective, industrial programming, like, it's not really prepared to have that happen. But that's the only way I can see it working. And which is really, it's kind of just a flavor of pair programming if you think about it, just pairing, working with other people.
It's an idea that's been circulated quite a bit over the last 20 years, the master journeyman apprentice model.
Hmm.
where you bring in apprentices, they don't know anything. You have a journeyman who's been there for 2 years, teach the apprentice, and then the master supervises the
Hmm.
journeyman. It's been around. There's a number of companies that have adopted that model in order to train people, and it works very well, but it's expensive,
Hmm.
right? Because these guys don't hit the ground running. If you're doing a consulting company, for example, you don't let the apprentices write code for customers. You
Right.
just don't. The journeyman can do that, and then the apprentices are doing internal work and exercises and things. But it does produce the insights you're after. It's just a very expensive model. I think you're right in that that's a viable approach, and it might be the approach we have to adopt.
Yeah.
It's going to take some real change of mindset and change of heart from the biggest companies in our industry to
Tell
start
you
doing
what,
it that way.
this AI stuff ought to be changing an awful lot of minds.
It's true.
Yeah.
It's true.
Yeah. There you
Well,
go.
should we end on that, Brad?
Yeah. Let's
It's the
end on
quote of the
that.
day. This AI stuff ought to be changing a lot of minds is a good quote to end on.
Yeah. Well, thanks a lot for taking time,
Oh, my
Bob.
pleasure.
It was
My
a
pleasure.
enjoyable conversation, and I'll continue to be part of the crowd that says you're misunderstanding what Bob says when he says he's not reading the code anymore. Um, and yeah, it was a pleasure meeting you.
Good to
Likewise.
meet you guys too.
Awesome.
All right.
And what do we say, Scott, to all our 60 listeners out there?
Smash that subscribe button, rate and review. Tell all your friends, including your mom.
All right. See you next week, Scott.
I'm
Bye, everyone.
Nice to meet you, Bob.
Bye-bye.
This episode of the How Many CTOs Does It Take podcast was produced and edited by Saffron Hefta-Gaub. Our theme song was AI generated by Brad. Please follow us on all the social media platforms at How Many CTOs Pod. You can find us on YouTube, LinkedIn, Instagram, Facebook, Threads, X, TikTok, and Patreon, or at our website at howmanyctospod.com. And remember to rate, review, and subscribe on the podcast platform of your choice. Thanks for listening.